Today we will study about Archimedes principle. Archimedes principle is that the body immersed in fluid, body immersed in fluid is directed by some basic principles. The weight of the body immersed in the fluid is balanced by the weight of the external volume of the body. Weight of the external volume of the body through which the fluid is displaced. This will apply the buoyancy force upward on the body. It can be displaced in this form as fluids appear to provide partial support to the objects placed in it. When a body is wholly or partially immersed in a fluid at rest, the fluid exerts pressure on the surface of the body in contact with the fluid. The pressure is greater or lower surfaces the body than on the upper surface. As pressure in fluid increases with depth, the resultant of all the forces is an upward force called the buoyant force. Suppose that a cylindrical body is immersed in the fluid. The upward force on the bottom of the body is more than the downward force on its top. The fluid exerts a resultant upward force or buoyant force on the body equal to P2 minus P1A. We know that P2 minus P1A is equal to rho g HA. Now HA is the volume of the solid and rho HA is the weight of an equivalent volume of the fluid. P2 minus PA is equal to mg. Thus the upward force exerted is equal to the weight of the displaced fluid. This is Archimedes principle. It means to say that when anybody is immersed in the fluid, then it will be balanced by the buoyancy force. That buoyancy force is equal to the weight of the fluid replaced by external volume of the body. For totally immersed objects, the volume of the fluid displaced by the object is equal to its own volume. If the density of the immersed object is more than that of the fluid, the object will sink as the weight of the body is more than the upward thrust. If the density of the object is less than that of the fluid, it floats in the fluid partially submerged. It means to say, if the density is less, then the body is float. If the density of the object is more, then the body will emerge and sink in the fluid. To calculate the volume submerged, suppose the total volume of the object is VA and a part Vp of it is submerged in the fluid. Then the upward force which is displaced fluid is rho P G Vp, which must equal to the weight of the body rho A G Va or rho P G Vp or rho A by rho P or Vp by Va. It means the apparent weight of the floating is zero. In summarized form is written as the loss of the weight of the body submerged partially or fully in a fluid is equal to the weight of the fluid displaced. Now, the streamline flow, the study of the fluid in motion is known as fluid dynamics. The flow of fluid is said to be steady if at any given point the velocity of each passing fluid particle remains constant in time. This does not mean that the velocity at different points in space is same. The velocity of a particular particle may change as it moves from one point to another point. That is, at some other point, the particle may have a different velocity but every other particle which passes the second point behaves exactly as the previous particle that has just passed that point. Each particle follows a smooth path, and the paths of the particle do not cross each other. The path taken by a fluid particle under a steady slow is a streamline, defined as a curve whose tangent at any point is in the direction of the fluid velocity at that point as shown in the figure. The curve PQ is like a permanent map of fluid flow. We consider planes perpendicular to the direction of flux flow at 3 points P, R and Q. The number of fluid particles crossing the surfaces as indicated at P, R and Q is the same. Let the area of the cross section at these points be AP, AR and AQ. The speed of fluid particles are Vp, Vr and Vq. Mass of the fluid particle delta MP is equal to rho P, Vp, AP delta T in time delta T. Similarly, at R point, the mass of the fluid is rho R, Vr, AR delta T, and at Q, rho Q, Vq, AQ delta T. So, rho P, AP, Vp delta T is equal to rho Q, AQ, Vq delta T बराबर rho R, AR, VR delta T. For flow of incompressible fluid, rho P is equal to rho R is equal to rho Q. इसलिए AP बराबर Vp बराबर AR, VR बराबर AQ, AQ and AV is equal to constant. This is called equation of continuity. This is a statement of conservation of mass in flow of incompressible fluid. A steady flow at low speed. Beyond this speed, the speed is called critical speed, and flows losses the steadiness, then it is turbulent flow.